All right, so today we're going to start looking at inverses, and we're also going to possibly get into Crammer's rule, although that might be a separate video. So last week we learned about solving systems of equations using graph substitution and elimination. This week we're going to learn how to use Crammer's rule or a matrix to find the solution of a system of equations. So a matrix, got a silly little video for you. I wish the sound was on this one, but there's no sound with it. So just my silly little thing. No, not that matrix. So if you don't know what that is, it's a movie. So a matrix is an array, which is a simple table of numbers organized in rows and columns. We will need two matrices to solve for each variable. There's the coefficient matrix and the constants matrix. To create the matrix, we write the coefficient or constants for the equation without any variables in a simple table format. So we're going to go to the next page here. Okay, so I just scooched this up so we can continue reading it. It just should be on your notes page. We're just kind of reading down the page. So the rows and the columns are specific, meaning that you can't just write them however you want into the table. This first column represents the first variable values. Usually the first variable is x. The second column represents the second variable values. That's usually y. It doesn't have to be x and y, but a lot of the time that's what we're using is x and y. Then we also have the first row represents the first equation. So row goes from right to left. So it's the first equation in the first row. And then the second row represents the second equation. So they're very specific. It goes x is for the first column, y is for the second column, first equation, second equation for the first and second row. So if I look at these, I'm going to highlight now so that you can actually see some of this. So first column represents the first value, so I can see here's my first column in the matrix. So this is what it looks like. It's just a bracket, and we're just going to put numbers into very simple little columns and rows. So I have 2 and 3, 2 and 3. So those are my x values. The second row represents the y values. So I have 4 and -8 for my y values. Now we're going to look at the rows. So I have the first equation, that's going along the top, 2 and 4. The second equation, that's 3 and 8, and that's going along the bottom, 3 and -8. And then, so this is the coefficient matrix. So that was just kind of a long explanation on how to set that up. You're literally just grabbing the numbers 2, 4, 3, -8, and putting them without variables. Make sure they're in the right order. You can't have 2x and 4y and then 8y and 3x. They have to go x, then y. Same order for the variables. And again, doesn't have to be x and y, but that's generally what we're looking at. And then we have the constants on the end here. We have 16 and 3, so that's where we put the constants matrix. We just have it in its own separate little area. And again, it represents the two equations. So this is the first equation, this is the second equation. All right. So to solve for either x or y, we're going to need to find what's called the determinant, the x determinant, and the y determinant. So we have 3 things to find. To calculate the determinant of a 2 by 2 matrix, that just means that it's 2 rows by 2 columns. We use cross multiplication and then subtract the 2 results. So here's an example. If I have this, and D stands for determinant, equals, here's my matrix that I just created up above. So I have 2 times -8 and then 4 times 3. So I'm cross multiplying. And so I get -16 minus 12, and the minus is part of the equation, but it's in there. Or part of the formula, I guess you'd call it. And then, so -16 minus 12, they're both negatives. I'm going to add and keep that negative sign. So the determinant on this one is -28. So that value is going to help us find for either x or y or both. So if I scooch down a little bit more here, so this is where we were just a second ago. So now to find the solution, we will divide either the x determinant or the y determinant by the main determinant we just found. So I know that's a lot of using the same word there, but so the x and y determinants are found by replacing this specific column, so either the x column or the y column, with the constants matrix, and then you cross multiply that, and that gives you the determinant for either x or y. So in this one, I'm just looking at the x determinant, so I'm taking the matrix we wrote up above, and instead of 2 and 3, I'm going to replace this x column with the constants matrix, which is 16 and 3. Remember, constants matrix is just what the two equations equaled. And then I'm going to cross multiply, so 16 times negative 8 and 4 times 3, and I'm going to subtract those because that's what we do with the determinant. So we have negative 128 minus 12, and I get negative 140. So I take those two numbers, the negative 28 and the negative 140, and I divide. It's the specific either x or y determinant divided by the main determinant. So negative 140 divided by 28 is 5. So this is simply just another way of finding the solution to a system of equations. It's definitely a different way because we have to learn how to set it up a little bit more, but it was kind of like the idea of synthetic division back a few chapters ago when we were doing that. It's just a different way of looking at solving a system of equations. So I hope that helped, and I will see you in the next video.